Good evening. I'm Hanlin Chen, and I'm studying for a master's degree from at Cranfield University. I'm very happy to be here today. I would like to talk to you about an overview of web robot detection techniques. Web robot detection has become a popular topic. In 2019, a report from DCO Networks has shown that web robot traffic has accounted for 40% of web traffic. Half of them are bad robots, and this number will continue to rise. This may pose a threat to some traffic-focused websites or even the security of the Internet of Things. After my presentation, I hope you can have a basic understanding about the popular web robot detection technology and the research gap in this field. My presentation is divided into three parts. First, I will introduce the concept of web robot, the aims and benefits of the review, and the three themes in web robot detection. Second, I will walk you through the key definition, the existing works, and the challenges in the three themes. Finally, I will present the identified gaps and conclusions, some of which were proposed by other researchers, and some are ours. Let me start with some general information about web robot. A web robot is a computer program that travels across the internet and collects data from web pages autonomously. Figure 1 shows the structure of a web robot and its crawling loop. The basic goal of a web robot's job is to grab the information on the target website and store it for future use. You may not be familiar with it, but you must have used it because the most common use scenario for web robots is search engines, such as Google. However, it could be misused to perform bad activities such as distributed denial of service attacks, which can cause serious damage to traffic-focused websites or companies. Okay, we've looked at what web robots and what they can do. Now I'd like to present the aims and the benefits of the review. First, we hope to identify the challenges and the research gaps of the three themes. Second, we will conclude the difference between the three themes. And last, we hope our work can be helpful for the security of IoT-enabled systems and services. The three themes are three popular directions for detecting web robots that we have summarized through the literature review. They are web log analysis based on machine learning, honeypots, and online robot detection. So much for the introduction. Let's move on to some details. The first theme is web log analysis using machine learning modules. So just in case you are unfamiliar with web logs, I would like to explain briefly. Whenever a visitor browses a website, the server will automatically generate a log file. Each log usually has many columns, which record the information of the visitor, such as the IP address and the server name. These columns are often referred to as features in machine learning process. The general process of web log analysis is to use thousands of web log records to train a model with a labeled dataset, telling it which records are generated by robots and others are generated by humans. Then let the trained model to predict unknown records to detect web robots. Let's now look at the table 1. As you can see, there are 4 methods listed here. I cannot tell you the technical details of them due to the time constraints. If you are really interested, you can pay attention to the references, which will be displayed at the end of today's presentation. The second column shows the datasets used used in these methods for training. The third column shows the number of features used to train the models, and the remaining 3 columns are the evaluation scores of these methods. From the table, you can see that the NNGE inference system achieved under a fixed number of training samples. The predictability of the classifier first increased with number of dimensions or features used, and then decreases. It seems that the NNGE system has the best accuracy in offline detection, but it does not mean that NNGE system is the best system. Because all methods were trained and tested on different datasets, it is hard to say which one has better performance. This leads to the second challenge in the field, which is positive case labeling. To be more exact, we do not have a standard dataset for web robot logs for machine learning. I think it is necessary to build a standard dataset with the label so that a newly developed system could be tested on it. The third challenge is that they could not detect and block bad robots in real time. The last challenge is accuracy. This is also a very important motivation for researchers. Of course, we hope to achieve an accuracy of 100%. Now we have looked at the first theme. Let's move on to second one, the honeypot. The definition of honeypot here is given by Wikipedia. I would like to add a little explanation. To put it simply, honeypots are usually invisible hidden links. As you can see in table 2, there are 3 different systems where honeypots played different roles, and 2 of them claimed that they have some benefits in a way. But when you look at the setbacks of these systems, which was also made clear in their papers, you will find that 2 of them concluded that the honeypot system gave a high false positive rate, and good bots could be trapped too. These 2 conclusions raised the same issue. False positive means their system incorrectly classifies human or good bots as bad bots. So we think main challenges of the honeypots should be summarized as follows. Firstly, it could drop the performance of a web browser. Secondly, normal users could be trapped by mistake. Thirdly, honeypot defense techniques can be thwarted if web robots are employing certain countermeasures. So much for honeypot. Let's look at the last theme, online web robot detection. Online detection means a system can detect, identify, or even block bad robots when they are browsing a web page. In table 3, we have listed 2 online detection systems. The detection method of path marker is inspecting the relationship between web pages or requests. Figure 2 is the flow chart of a path marker system. In this system, machine learning techniques, machine learning detection, heuristic detection, and capture verification were employed to detect web robot sessions. Heuristic detection is widely used in virus detection, and capture verification is letting users to recognize twisted letters or numbers, which is also widely used in some websites now. Path marker can trace the page that leads to the access to an URL, by URL by adding a marker to the URL and identify the user who clicks this URL using the extended log table. This seems to be a more effective method, but even so, with the development of machine learning technology, some crawlers can also pass captcha verification. The second method is a bit like the first one. It also uses machine learning to check the relationship between user requests to decide whether a session comes from a web robot or human. The application of a word sequential probability ratio test had never been used to detect web robots before. Since this method has been proposed for a short period of time, there's currently no commercial application. Its performance is only based on experiments. Judging only from the test accuracy given in their works, these systems are not as accurate as offline detection systems. This means that there is room for improvement. From the point of view of benefits, both systems seems to suppress distributed crawlers to some extent, but there is no mention of other type of web robots. Well, let's look at the challenge of online detection. The first challenge means that there are many types of web robots now, and we are not sure which types of web robot might crawl a website. The second one means that we have no standard definition of the form of web robot sessions, just like the positive case labeling we have mentioned before. The third one is different from the first one. That is, there may be new types of web robots which are unknown. Web robots for the existing system. The last one means that the accuracy of its existing online detection system seems to be lower than that of offline detection systems. This may mean that the performance of online detection system can be improved. That's all I have to say about online web robot detection. Now, let's move on to the final part of the presentation, our conclusions. Some of these conclusions may have appeared earlier, but I would like to put them together so that you will have a deeper impression. The first one is that we believe that a standard web robot dataset is very necessary because this will provide a reliable data support for future research. The second one needs no further explanation. Thirdly, we hope to develop a detection system that are able to detect all types of web robots in real time. Fourth, we hope that the system for distributed web robots can have a better performance. The last one is a small tip that honeypot technology is best not to be used directly as a classifier. Okay, we're almost done. Here follows the reference. And thank you for your attention. Now, if you have any questions, I'll be very happy to answer if I could.
Thanks, Hanlin. Okay, so we have a question. It's a bit long, okay? So let's try to get through it.
Okay.
So Tim is asking, in my own experience, modern bots operate from multiple IP addresses and different HTTP headers for successive requests. This allows them to perform what might be called a bow tie style of attack, where each request is unique in terms of classification of its origin and unique in terms of the requested URL. This style of web scraping cannot be blocked even by leading web application firewalls, for example, Incapsula or Cloudflare, which have visibility of request patterns from all around the internet. Does your research address this style of web scraping?
Sorry, my research didn't cover this kind of web scraping. Sorry.